All right, perfect. All right, sorry guys, we already did example 1 on the warm-up. I have to do this for the video, I'm sorry. We already did example 1 on the warm-up, which you should know how to do. Just solve this for y to get it in y equals mx plus b form. Okay, now in problem number 2, I purposely used the same problem. Now you have to be able to take an equation that is in slope-intercept form, and you have to rewrite it in standard form, which means you have to get it back to that. Make it look like this again. Well, guys, if you remember, standard form is this formula. So I always just think of standard form as x and y have to be on one side of the equal sign together, equal to a number. So that's what you have to do here. You have to get x and y on one side of the equal sign, equal to a number. So guys, if this was just 2x, how would you get 2 x's to move over here? Minus them. So just minus the 2/5 x. All right, so they're gone. Now I'm going to put my x's first because we like the ax term to be first. So I'm going to put my negative 2/5 x. Then I'm going to put the positive y that was already on this side. And now it's equal to, the only thing we left over here is negative 3. Okay. So we're looking more and more like standard form. Standard form has 2 conditions that you have to make sure you have met. Once you get x and y on one side, 2 things you have to check. Number 1, no fractions. You are not allowed to have any fractions when you are in standard form. So we're going to have to get rid of that fraction. The second condition for standard form, and it's a weird one, but it's a condition, and it just makes sure that we all end up with the exact same answer. The second condition is the number that you leave in front of x is not allowed to be negative. It has to be a positive number. Okay, so let's get rid of the fraction because we're going to be able to get all of these conditions met by trying to get rid of the fraction. So guys, we're going to use the same strategy we used when we tried to get rid of fractions in an equation. So we're going to look at the bad guys, the bottom. Who's the only bottom in this problem? Is 5. Now we would normally take a look at all the bottoms and then we would find the least common multiple of your denominators. But guys, if 5 is the only bottom, what's the least common multiple of a 5 and nothing else? It's 5. So 5 is going to be our magic number. So now you take that magic number, if you remember, and you times all your tops by it. So I'm going to times this top by 5, this top by 5, and this top by 5. Okay, but before we do that, we said that the second condition was that the number in front of x that we end up with is not allowed to be negative. So all I have to times a negative number by to make it positive is another what kind of number? So make this magic number negative 5 instead of positive 5. So now we're going to use negative 5 as our magic number. And we have to do the same thing to everything. So it's not like I can use negative 5 here and then positive and positive. It's got to be the same number all the way through. So if the number in front of x was already positive, then we wouldn't need the negative sign. But if he's negative, then use a negative magic number, okay? All right, now watch this. Everything should fall into place. Go ahead, Dad.
You don't need the negative number because out of the negatives for the 2/5.
This one has a negative because you minused it over, so it was negative 2/5 x.
Oh, I didn't do that.
All right, yeah, it should be negative, okay? All right, so now watch this, guys. Everything should fall into place. What's negative 5 times negative 2? 10. What's 10 divided by 5? 2 times x. And look, we're getting closer to what it originally looked like. All right, what is negative 5 times positive y? Negative 5y, which is exactly what we needed, equals, what's negative 5 times negative 3? 15. And that's exactly what we needed. So now it's back in true standard form. Now again, some students are like, well, Hardy, if I took that and made it look like this, I already know he is going to go back to that. Why do I have this? Because in the problem, guys, you're not going to see this first. You will have only seen this, and you're going to have to convert back to his standard form. So you won't know what it looks like. All right? Question? Did you have a question, Darren? No? Okay. All right, then we're good. So like I said, we're going to have to do this when we start working in section 4. Let me give you your notes, and then we're only going to do the definitions, and then we're going to stop. No homework.
I'm that good.
I stole the I got you. So guys, please don't lose these notes because we're going to use them again tomorrow, and I won't have that many extra copies. Okay. All right, here we go. Everything we are about to write down is review. But these are all the things that you're going to have to know off the top of your head when we start writing the equation of a line. This is all stuff that they might tell us as a clue that we're going to have to use to write the equation of a line. So hopefully we remember what all this stuff is, but I want you all to have it in one place in writing. All right, if we're going to write the equation of a line, slope is never going to go away. As long as we are working with linear equations, straight lines, we're going to be dealing with slope. So we know slope is m. He's a rate of change. He's the change, your vertical change, compared to your horizontal change. So we call that the change in which coordinate on top? Y over change in x. So to find the change in y, we subtract our y coordinates over. To find the change in x, we subtract our x coordinates. So you're going to have to still deal with slope. All right. Another clue they might give you is the y-intercept. Now, the y-intercept, guys, we know that he is a point directly on the y-axis. We also know that he's the b in y equals mx plus b. So you should be very comfortable with the y-intercept. But guys, if you're a y-intercept and you're right on the y-axis, you clearly have a y-coordinate, but what does your x-coordinate have to be? 0. So pay attention to that, because the y-intercept is a really good piece of information to know. So if they're going to try and sneak it by you in an ordered pair, if they tell you it passes through the point 0, 5, you got to have like a neon flashing sign that goes off. Wait a minute. The point 0, 5 is a y-intercept. It has an x-coordinate of 0. All right, the x-intercept. The x-intercept, he's the point directly on the x-axis. That's where your line will cross over the x-axis. So guys, clearly he has an x-coordinate, but what does his y-coordinate have to be right on the x-axis? 0. Remember, the minute you hear intercept, that means they are on an axis and one of their coordinates has to be 0. All right, I told you when we first started dealing with the x-intercept that when we get to chapter 4 and chapter 5, the x-intercept is going to be really, really important. And he has a nickname, and his nickname is the 0. If you are ever asked to find the 0 of an equation, or the 0 of a function, or the 0 of a graph, guys, that is literally you being asked to find its x-intercept. And the reason the 0 is his nickname is because he is the number that makes 0 come out. He is the number that will make your equation equal 0. So he is known as the 0. All right, this should be nice and fresh. Guys, parallel lines. If they even mention the word parallel, then they are trying to give you a clue about what piece of information? Slope. It is a slope clue. If they mention parallel, if they mention perpendicular, then they are trying to tell you something about your slope. All right, and we know parallel lines have to have what kinds of slope? Same slope.
Please find this interruption. Bus number 154 will be bus number 108 today. And 195 will be bus number 190. Once again, 154 is 108, 195 is 190. Thank you.
Okay, so again, if they say you have to write the equation of a line that is parallel to this line, then you know you need that line slope because your line has to have the same slope as a parallel line. All right, then we saw perpendicular lines. If they mention the word perpendicular, they are trying to give you a clue about what your slope needs to be. And we know that perpendicular lines, what are their slopes to each other? Two things, reciprocal and opposite sign. So their slopes are opposite in sign. One has to be positive and one has to be negative. And they have to be the reciprocal. And they must be both conditions, not one or the other. Okay? All right. Then you may be asked to write the equation of a line that ends up being a horizontal line or a vertical line. And I always consider the horizontal and the vertical lines are special kinds of straight lines. So to me, there really isn't like an algebraic technique that I'll show you to write an equation of a horizontal or vertical line. It's more like you're gonna have to reason this out with what you know about a horizontal and vertical line. So let's remember what we know. A horizontal line, guys, is it flat or up and down? Flat. Horizontal lines look like this. So the slope of every single horizontal line, guys, think about it. Rise over run. Well, it doesn't rise at all, but it runs all day. So that would be 0 over a number, which means what's the slope of a horizontal line always going to be? 0. Another thing I want you guys to recognize about a horizontal line. Guys, when you are working with a horizontal line, which coordinate, the x coordinate or the y coordinate, never changes? Which one never changes on a horizontal line? The y. X is changing like crazy. You're moving right, you're moving left, but are you going up or down at all? No. So the y coordinate never changes. Every single dot on this line has the same y coordinate. So since the y coordinate never changes, his equation always ends up being then y equals that number that never changed. So his equation always ended up looking like y equals a number. Remember, their equation only had one variable in it. So if every single point had a y coordinate of 2, then that just ended up being the line y equals 2, the coordinate that never changed. So when you go to write their equations, guys, it almost takes no work. They should be extremely quick and extremely simple. All right, what about a vertical line now? A vertical line then must be the one that goes up and down, which means, guys, you're rising all day long. You're going up, you're going down, but you're not running at all. So your slope is a number over 0, which always ended up making the slope who? Undefined. The slope of all your vertical lines were undefined. Up and down, undefined. All right, well, guys, now think about a vertical line. When you go to write his equation, it's going to be more of a mind game than it is a math game. Which coordinate never changes on a vertical line? X, right? We're not going right, we're not going left. We're going up and we're going down. So y is changing like crazy, but x never changes. And since the x coordinate never changes, then his equation just ended up being x equals that number that never changed. So if every single x coordinate had an x coordinate of 4, then that line would be x equals 4. Okay? Because as easy as they are supposed to be, when you go to write their equation, you guys can get very confused. And I understand. You got to think about which coordinate doesn't change. All right, and then the only other thing I want to go over with you guys is when you go to write the equation of a line, you have formulas. You have different ways that a line can come in. So you have to know which formulas you want to use. So if you're going to have linear equations, the first form they come in is our favorite, good old slope-intercept form. What does that look like? Beautiful. Okay? And when you are in that form, M always represents the what of the line? Slope. And B always represents the beautiful. So guys, if a problem says, hey, write the equation of a line that has this slope and this y-intercept, you're going to write that equation in about 3 seconds because you're going to put the slope in for M, you're going to put the y-intercept in for B, and you just wrote the equation of a line. So definitely, the best information they can tell you about a line is slope and y-intercept. That's what we hope for. Please tell me the slope, please tell me the y-intercept, because you'll be able to write the equation very quickly. But obviously, math is not that nice, and that's not always going to be the information they tell us. But I definitely want you guys to put a big box, stars, neon flashing signs, whatever you got around that formula, because that is going to be your go-to get started formula every single time. I know you guys can memorize it. I know you know who is who. So that is how I'm going to teach you to do these problems. That's going to be our magic go-to formula every single time. Okay. Even though we're always going to start here, sometimes the problem is going to say to write your final answer in standard form. So you got to know what standard form of a line looks like. And what formula was that? You just said it before. Beautiful. Perfect. AX plus BY equals C. Guys, you will never start a problem with that formula. All you might have to do is make your answer look like that in the end, but you will never get started with that formula. Okay, and the reason is when you're in that form, A, B, and C, guys, they're just numbers. They're not the slope, they're not the y-intercept, so they're just random numbers at that point. All right, now I haven't said this to you guys yet. There is a third form of a line, and you should definitely recognize this from Algebra 1. However, I'm going to have you guys write it down, but I never make you use it. It just makes me feel better having known that I at least told you about it, so you can't say I didn't tell you about it, but we don't need it. We can get everything done with this formula, and you guys know that formula, and you have it memorized. So to me, there's no reason making you use a formula that you're probably never going to memorize, all right? But I do need you to know it. I just want you to have it in your notes so it's there. It comes from, it's called point slope form of a line. It comes from the slope formula. This is how we find slope, right? So if you put this over 1, because that's just over 1, and you cross multiply, you create point slope form of a line. Do not write this down yet, because I'm going to fix it. Just watch me first. So if I cross multiply, do not write this down yet. Steven, do not write it down yet. All right, you're going to do this times that, and you're going to get y2 minus y1 equals, do not write this down. And then you're going to cross multiply, and you're going to get m times this, which is that. The only difference is we just, in the actual formula, take out this subscript. And the point slope formula gets known as y minus y1 equals m times x minus x1. And it's for you guys to use when they tell you about a slope and a known point on the line. Because m will represent the slope, and then x1 and y1 represent a known point. Like they would have to say, hey, your line goes through the point 2, 3. And then x1 would be 2 and y1 would be 3. But guys, like I said, I'm going to let you put an X over that one because I'm never going to make you use it. Nobody ever remembers it. And like I said, we can get every problem done with the formula that you all know. So I don't use it, but if anybody plans on going on to calculus, you're definitely going to see this in calculus. But if you're like, dude, I'm good, then you'll be fine. You'll be absolutely fine. Yeah, this was the one I want you to write down. Okay? All right. So guys, I'm going to stop there. So this is everything we're going to need in order to write the equation of a line. So tomorrow we'll come in and we'll just start practicing examples. So no homework tonight. This is our second night in a row. Enjoy it. And like I said, tomorrow we'll come in and finish the notes, so don't lose them.